Good day to all of you. In today's session, we shall see two relational algebra operations from set theory in DBMS, that is union, intersection and minus operations. If we take two relations R and S, what is R union S, what is R intersection S, and what is R minus S? U is the symbol for union, inverted U is the symbol for intersection, and this minus symbol is symbol for minus or set difference. We'll see with an example next. For any set theory operations, the two relations must be compatible. That is, if we take two relations, student and instructor, in both the number of columns and the type of columns must be same. If there are two number of columns here also there must be two. And if they are of integer type, here also integer type. Or if float type or string type or any type, the number and type of columns in both the relations must be same for any set theory operations. So if you take the student relation as R and instructor relation as S, R union S or student union instructor, it will have all the rows from student relation and all the rows from instructor relation into this, but which are common, they will be present only once, no duplicates are allowed. So this Susan and Ramesh, they are present in both, but they will be present only once in the student union instructor. So that is what we say, no duplicates are allowed. Next, R intersection S or student intersection instructor, it will have only those rows which are common to both. So only common rows it will be having in student intersection instructor. Next, R minus S or student minus instructor, it will have all the rows from student, but it will exclude only those rows which are present in instructor. Hence, it will have only these rows in student minus instructor. Similarly, S minus R or instructor minus student, it will have all the rows from instructor relation, but it will discard those rows which are present in student, that is Susan and Ramesh. It will discard these rows and remaining only these three rows will be present in instructor minus student. Union operation is commutative, that is R union S is also equal to S union R. Union operation is also associative, that is R union S if you do first and with the result if you do union of Z, that is equal to first you do S union Z with the result if you do R union, it gives the same result. So union operation is both commutative and associative. Similarly, intersection operation is also both commutative and associative. But set difference or minus operation is not commutative. It is not also associative. Okay. Next we shall see an example which shows the application of one of the operation from set theory, that is union operation. So in this example what is done is, the employee relation is taken. There are 10 columns and 8 rows. In such a big information, only SSNs of the employees who belong to department number 5, who are working either as employees or supervisors. So SSNs of all the employees who are working for department number 5 either as employees or supervisors, they are collected. So that is what is the aim of using union operation here. How that is done we shall see next. For that these 4 steps of operations are done. They are shown in these 4 relational algebraic expressions. First expression does select operation taking employee relation as input. Then it select only those rows where department number is 5 and the result is saved in DEP5 underscore EMPS intermediate relation. So that DEP5 underscore EMPS intermediate relation will have 1, 2, 3, 4. Only these 4 rows, because in employee input relation, only those 4 rows belong to employees having department number 5. In second relational algebraic expression, taking DEP5 underscore EMPS intermediate relation as input, only SSN column is projected or selected. Hence, in these 4 rows, only SSN column means 1, 2, 3, 4. Only these 4 values are taken and they are saved in intermediate relation result 1. So, this is result 1 intermediate relation. In third expression, project operation is there. It takes same DEP5 underscore EMPS relation, that is these 4 rows. In that super SSN column is projected or selected. So this time super SSN is here. Only these 4 values are collected and they are saved in another intermediate relation, that is result 2. So this will be result 2 intermediate relation. Now union operation is used here. Result 1 union result 2, that is saved in result final table. That is result is the final relation or table in which both result 1 and result 2 are present. Means these SSNs and super SSNs will be present in final relation, that is a result. Now our target is served, that is from this employee relation the social security numbers of all the employees who belong to department number 5 who are working as employees or supervisors. Their SSNs are saved in result relation. Okay. This is how union operation is used here. Union operation could be done on the two relations result 1 and result 2 because they were compatible. This had only one column SSN, this had also only one column super SSN. Both were of the same type. So number and type of columns in result 1 and result 2 were same, hence they were compatible, hence we could generate union of the two relations, that is result relation, which has SSNs of all the employees belonging to department number 5. They may be either working as employees or supervisors. Okay. So from this input relation and these 4 steps, we have result 1, result 2 and union of the both, which will be having the SSNs of all the employees belonging to department number 5 working either as employees or as supervisors. That shows the example of one of the set theory operation, union. This way, set theory operations are used in many practical applications. With that, we come to the end of discussion on relational algebra operations from set theory in DBMS, that is union, intersection and minus operations. Prior to this, it would be better if you had watched my previous 3 video sessions, one on select operation, another on project operation and the third one on sequence of operations and renaming. Then it becomes easy to follow this. I hope you understood. Thank you.